All right, this is the first video on chapter 2, and we are going to jump into section 2.1. Section 2.1 is on atoms and their components. Okay, so if we look at an atom, we basically have two major areas that we talk about. We talk about the nucleus, and around the nucleus, we have this region that we call the electron cloud. Now, usually we talk about atoms being made up of three subatomic particles, right? What does subatomic mean? Subatomic meaning smaller than an atom. Okay. The first of these that we're going to talk about is the proton, right? A proton is a positively charged subatomic particle. And typically we assign that charge or assign the charge of a proton as having an arbitrary value of +1. Right now, if we wanted to get more technical and we wanted to give actually an SI unit, the SI unit for charge is something called the coulomb. We could specify this in terms of coulombs, but for purposes of chemistry, just calling it +1 gets straight to the point and is a lot easier for us to use most of the time. But in any case, the charge is +1. Now, subatomic particles are matter, so they do have mass. Yeah, the mass of a proton, of course, is tiny. The mass of an individual atom is tiny. If we wanted to give this mass in grams, it would be about 1/6.02 times 10 to the 23rd grams. So in other words, a very, very tiny mass. And for convenience sake, and also just because it's more useful to us most of the time, we assign the mass of a proton as having an arbitrary value of 1 AMU. It's not actually exactly 1 AMU, but that's close enough for anything we would need to worry about in this class. Now, our next subatomic particle is called the neutron. Right? Neutrons are neutral. They do not have a charge. But they also have but their mass is also about 1 AMU. Proton is a little bit more massive than a neutron is a little bit more massive than a proton, but not enough for us to really worry about. Our third one is called the electron. Okay. Electrons are negatively charged. Their negative charge is of the same magnitude as the positive charge on a proton. So we assign the charge on a proton as having an arbitrary value of -1. Now, electrons are mass, but their mass is tiny compared to a proton or a neutron. And so typically for our purposes, we are going to consider the mass of a proton as being 0 AMUs. Now, can it actually be 0 AMUs and still be considered matter? No, it can't. And if we were to measure the mass of an electron, which can be done, we would find that it's about 1/2000th of an AMU. So again, the mass is there. It's just not enough for us to worry about. Now, within the nucleus, we find protons and neutrons. And of course, in this area outside the nucleus called the electron cloud, we find electrons, right? So protons and neutrons are in the nucleus, electrons are in the electron cloud. All right, if we look at the nucleus, of course, it's going to have some number of protons and typically some number of neutrons in it. Okay. Now, it's a section 1.2 topic to talk about what and how many of each are in there. But let's say we have a hypothetical atom where we have 6 protons. I'm just going to illustrate them as a P. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's our 6 protons and 6 neutrons. Now, in this particular atom I'm illustrating, our number of protons and our number of neutrons are equal. That is not necessarily the case, but it can be, and it is the case in this particular one. All right, if we look at this, each proton contributes a +1 charge. Each neutron does not contribute a charge. We want an overall neutral atom. All right, we want an overall neutral charge. So if we have 6 protons here, we need 6 electrons in our electron cloud. 1, 2, 3, 4, 5, 6. All right, now let's look at this. Okay. In our nucleus, we have 6 protons and we have 6 neutrons. I know I've said that a bunch of times already. So our nucleus is going to have a mass of 12 AMUs. Okay, each proton is 1 AMU, each neutron is 1 AMU. Now, notice that we also have 6 electrons, but remember, the mass of an electron is tiny. So we don't really consider these as contributing to the mass of the nucleus, or I'm sorry, as contributing to the mass of the atom. So this is going to be our mass of our atom. It's 12 AMUs. But if we look at atoms, okay, each individual atom, of course, in and of itself is tiny. But our subatomic particles are even tinier. Protons and neutrons are a whole lot bigger than electrons, but still, they're packed in really tightly here in the nucleus. The electrons are tiny, but they're spread out. And this is really actually a poor illustration of how spread out the electrons are outside the nucleus. Really getting into the details of atomic structure is way beyond the scope of this class. But we could actually look at in quite a bit of detail exactly how the electrons spread out in the electron cloud. But if we look at this though, the nucleus, relatively speaking, is extremely dense. Actually, not relatively speaking, the nucleus is very dense for the amount of mass inside of its volume, or for its volume. Very, very dense. The nucleus contributes essentially all of the mass of the atom, but it's physically tiny. The electrons are spread out, so electrons contribute most of the volume to an atom. Now, we have these, or I should say the electron cloud contributes most of the volume to an atom, because that's going to lead into the next point I'm going to make. We have these teeny tiny particles floating around out here in this region. And so that means that the electron cloud does contribute the majority of the space, or the majority of the volume of an atom. But because there are only so many electrons in this huge region, most of an atom is actually empty space. Okay. That covers the structure of an atom.